Hello, my name is Marco Bertaccini. I work for AEB. I'm here to present a new line of filters from Danmil, a company that AEB acquired a little over a year ago, based in Denmark, specialized in filtration. Probably familiar with the cartridges. We're now introducing models and filtering sheets from Danmil. Filtering sheets and models are mainly formed by four ingredients: cellulose, DE, perlite, and resins. Not all the producers use these ingredients. We have a lot of filters out there that are just made with cellulose and polypropylene fibers. We use this for four different reasons. Cellulose is there to give a structure that is also flexible. There is also a charge associated with cellulose. Charge is really important to block certain particles that are charged. There's DE, which is fossil flour coming from algae that were growing in the bottom of the ocean, in the bottom of the sea, millions of years ago, and they fossilized. And the structure that they have is very interesting because it forms different channels that the wine going through these channels loses particles. So we make a flour out of it, and we put them in the sheets. The more flour you put, the more the pores get tighter, and the more the filtration ends up being sterilizing. Basically, the wine flowing through these channels loses the particles. So the more you have, the better. There is perlite, that is there for giving a sturdy structure to the sheets. Resins have a charge as well. They're there also as a binder to keep everything together. But let's not forget about the charge. The charge is a positive charge that will interact with the negative charge of colloids, yeast, and bacteria, retaining those particles. Here is a chart of production of the sheet. It's a fully complete chart that you can check. Basically, we have a tank where the mixture is formed in a liquid media. You put all the ingredients that we just mentioned. Then it's all a matter to trying to get a little drier. So there is a vacuum, a rotary filter. Everything goes in a belt, like a treadmill, about 60, 70 meters treadmill that has cavities underneath and pumps that create a vacuum to suck more liquid. When it gets to the oven, you see here, we're going to have about 3 to 5% humidity. So in the last part, when there is the formation of the sheet, we lose all the rest of the water. And then there is a cutter. In our case, the cutter now is a water jet at about 12,000 bar that does a perfect cut that creates a very smooth edge, no fiber sticking out. It's a very precise surgical cut for a very, very high quality filter sheet and modular disc. Here we see the sheet coming out of the oven press. From this, we can cut with this jet, with this water jet, we can cut the squares, the 40 by 40 squares, the 60 by 60 squares, and the circles for the Danmil models. The way these filters will work is a little different from the cartridges. We have three ways of filtering inside the same filter. Seating, so basically a strainer, no big particles will go through a small pore. Depth, that's where the channels formed by the DE come in play. The liquid goes through all these channels and the particles get stuck in the various corners of the maze formed by the channels of the DE. So we'll call it depth, is about a 4 millimeter thickness where all these particles have a chance to get stuck. In this maze, there is also the absorption from the charges of the cellulose and the charges of the resins. We talked about our charges being positive and the colloids, the bacteria, and the yeast being negative and getting stuck with these charges. Here's a little representation, schematic way. You see the big particles, they don't even get in the first part of the filter. This is the seating action. And then all these maze where all the particles get stuck, and then the absorption is a little bit everywhere where you can find cellulose and charges in general. Obviously, it's very important to get the right size of pour for the right wine. If you have a wine with big solids, you definitely don't want to have a narrow porosity because you're going to end up with a rapid clogging of the pores and a very low filtration yield. The opposite, if you have a very dirty wine and very wide pores, a lot of this solids will go through the filter and you're going to end up with a dirty wine on the other side. Actually, it's very deceiving because at the beginning of the filtration, in this case, you're going to get clean wine. Why? Because the charges will going to retain a lot of the molecules, a lot of the solids. But as soon as the charges are neutralized, then the wine is going to come out dirty again. After all, filtration follows a physics formula. And the one thing that we need to consider is that the more surface you have, the better the flow will be. The surface, as we can see, is directly proportional to the flow. So the more surface you have, the more flow you have, the more regular flow you have. And that's what you want to have. So don't limit your stack of sheets to 10 to 15. Go to 30, go to 100 if you can fit those. You're going to have a smoother filtration and a wine that ultimately is going to recover from the stress of the filtration much faster. Other elements obviously are the pressure, the permeability of the sheet, the viscosity. If you have a cold wine or with a lot of gamma arabic, it'll be more viscous, your filtration will be slower. Thickness of the sheet or the filter media in general also will be inversely proportional to the speed of the flow. We talked about the electrokinetic potential, that's also important, so the pH plays a role during filtration. The lower the pH, the more charge you will have. So the lower the pH, the more effect of this electrostatic blocking of the colloids will be effective. If you have wines with high pH because of problem, a microbiological spoilage problem or something done in the vineyard, so the pH is high, your clogging will be a little faster because the colloids will go through, eventually get to the membrane. One thing also we have to consider, the sheets are not absolute. Their porosity is pretty wide. We see also here two references of the Danmil line, the DA70 and the DA50. They actually have pores size that overlaps. That doesn't happen in the cartridges. We know that a 0.45 will have no pores that you can find present in a 0.65. So two different items. We have to consider the sheets as nominal, not absolute. Filtration cost. This is an interesting subject because when you consider all the expenses, you always want to look at the cost of what you do. And filtering doesn't cost much. Here is a case, for example, that we analyzed, and we give you some numbers to calculate the cost. Filtration sheet, normally a regular filtration, let's call it a rough filtration, will filter 1,000 liters per square meter per hour. That means that a 40 by 40 sheet will filter 140 liters per layer per hour. What does that mean? If I put a stack of 100 filtering sheet, what's my filtration flow rate? It's 140 liters per sheet times 100 sheets that I just loaded. That's about 140 hectoliters per hour, more or less. So what's the maximum duration of my filtration cycle when I stack 100 sheets in my press filter? Let's call it 100 times 6 or 8. So I can filter with this stack 840 to 1120 hectoliters. So about 1,000 hectoliters. So what's my cost? 1.75, which is pretty much the cost of a Danmil sheet, times 100. That's about $175 for, let's call it 1,000 hectoliters. or 840 to be conservative. Cost per hectoliter, 20 cents. Cost per liter, 0.2 cents. Bottle cost, 0.15 cents. Very affordable for what it does for you. What's the downside of depth filtration? Or let's call it sheets filtration. First of all, you cannot change from white to red and then white again. You're going to end up with a rosé wine if you do so. Also, this is a system that puts the wine in contact with oxygen. It's an open system. Therefore, it incorporates oxygen, dissolved oxygen. It cannot be regenerated with a caustic wash because everything that goes through the filters a little bit stays in this material that is spongy. So if you get caustic in the filters, most likely, then it's going to go in the wine that goes through next. So no caustic wash, caustic regeneration. Other downside, when you're done with the filters, you have to stop operation to change the sheets. So if you have an operation that has to run 24/7, this is not an efficient system. It's going to stop your work. A lot of people also don't like seeing leaks, and sometimes you see leaks in this kind of filters. But first of all, we say don't blame it on the sheets themselves. Sometimes the problem is the seals, they're missing, they're not in good shape. So check the seals. How about the plates? Sometimes those plates are a little bent. There is never a good, when they're bent, there can be a good interaction between the sheets and the plates. So it's important you have that the screw is well greased so you can give enough pressure by tightening the screw. We really want a good pressure between the sheets and the plates to guarantee that there is no leakage, of course. How do you assemble the sheets on the filter? Well, first of all, we recommend that the rough part of the filter faces the direction of the inlet of the wine. So the wine coming through, it's got to go through the rough surface first, because the rough surface is the one with the larger pores. It's almost like your pre-filter in the little sheet. So if you actually put the smooth part first, then your filter is going to get plugged right away, because that's where the tightest pores are. Check the alignment of the plates. We said before, you want, have a good pressure between the plates and the filter. And then make sure you run some water. Don't soak the sheets. You don't need to put them on a tab and soak them. Just load them dry, and then have a good flow of water going through. Maybe with some citric acid. Run water for 5 minutes. Pressure should be about 1.5 times what you use, the pressure that you use when you filter your wine. Run the water for 5 minutes with citric acid, maybe. This way, the citric acid will get rid of that papery flavor that you get sometimes from the filters. And then you can sterilize the filter with hot water or steam. There's a little diagram that shows how the wine gets clean. So it goes inside the filter, through the sheet, in the plate, and out comes the clean wine. Here's the range of the Danmil sheets. We have, let's call it 3 categories. First category, the 06, 09, 12 HF, 15, 20 HF, and 30 for polishing and rough filtration. And then midway, the 40, 48 HF, 50, 70, 85 HF. And then almost a sterilizing, still nominal, but sterilizing sheet, 100, 110, 130, 140. How do you identify the right sheet that you need? We see here a reference chart that is the most specific that you can get, because it tells you exactly what kind of permeability each sheet has. And this is a standard measure that you can't really contest. This is how it's going to be. This is the sheet, and this is the permeability. Then there is this that is a little different, because this is done mostly with the pore size, and the material is different, the thickness is different, but pretty much this is a cross-match chart with competition. You can go back to it if you have to in a hurry, match something. Also, there are physical variables that you can use to identify the specific sheet that you need. So in this case, for example, using the filtrability index, more than 100, and you need a rough filtration. Then you'll need a DA30 in a white. In a red, it'll be different, DA15, DA20, and so forth. So with the filtrability index and the purpose of your filtration, you can get a match for what you need. Here instead, we're going in pre-filtration through filtration. So which kind of NTU you want to achieve, which kind of NTU you have, or which kind of filtration index you want to achieve is another chart that allows you to do so. So you want to end up with a filtration index less than 10, your NTU or here, and then you follow and you get the filtration cartridge or membrane or the pre-filter sheet that you need. So the Danmil deep filtration range will try to give you the best quality. And what does that mean? We're sourcing the best cellulose that we can. We source the best treated DE, minimize the calcium and iron intake, minimize the color absorption, give you the least leaking possible, trying to get the minimal paper taste, or at least make it easy to get rid of, give you thickness, that's important. We already spoke about the cut with jet water at 12,000 bar, laser control during production, and then as we know, Danmil has a very well-organized lab that ensures a very good QC and traceability. Here's a chart that is very interesting where you see some comparison with some of the competition. For example, the iron, the calcium, and the aluminum leakage, we're among the very best in the market. If you look at these numbers, you can go back to it for reference. Leaking, we have the minimal leaking that you can see among the competition. So these are values that you should consider when you look at these sheets. There's a chart also that you can go back as a reference to properly utilize these sheets, so it gets you the flow for each kind of range of sheets and models. And then other charts talking about pressure and turbidity. Bottom line, you don't want to exceed 1.5 bar delta pressure on the sterilizing sheets. You don't want to exceed 2.5 bar on the rough filtration. Otherwise, you're going to get some turbid line. You don't want to get pressure bumps. If you block the pump, and you're going to make something happen so that when you restart the pump, you don't get the pressure bump into the filter. So maybe start a pump over, but every time you have a pressure bump, you're going to get some turbidity coming out. Obviously, the lower the flow, the less the turbidity. And then when you do a regeneration, you cannot do a regeneration with chemicals. We already spoke. Normally, you can't do a backwash of the sheets, but you can definitely do a little bit at the end of the day if you still have some gallons to filter. Close the filter inlet and do a little backwash. You can do shake up a little bit of those solids, open up the pores. It's doable. As far as lenticular models, we also have some products that are new for our Danmil company. And we tried to produce the best we could. So something that hasn't been in the market yet as far as quality, all compatible with what's already out on the housing. So we have 12 inches and 16 inches, so 1.9 square meters and 2.7 square meters. They withstand an internal compression of 2 tons. We have very reinforced central stud, very easy to disassemble, has all the items from Danmil, traceable, and as I said, compatible with all housings. Here's a little chart that will cross-match the lenticular filters with the sheets. What's the difference between lenticular filtration and sheets? Well, first of all, we saw the sheets working in an open system to get oxygen intake. Not the case of the models. The models, they're stuck into the housing. There's no oxygen intake. You can also regenerate the models because they are in the housing, so that you can create a little turbulence and wash those housings. Never in the backflow, but they can definitely be regenerated. Not with chemicals, they can be regenerated. For the models, you cannot store them very well. They will resist maybe overnight, maybe a couple of days, but definitely don't stock them for more than 6 or 7 days. They'll get destroyed in the peracetic acid or the potassium metabite that you will have to use to store them. So in that case, they're not very practical if you don't filter for long cycles. There's a little chart that you can use to see how much each filter will do. So, like a 12-inch, what's the square meter total that you get? What's the flow, minimum and maximum per liter per hour? So one of the 12 inches will do a minimum of 1,000 to a maximum of 1,500 liter per hour, and the theoretical volume in hectoliter that they can filter before you have to replace them. Picture of the models. You see these little triangles here. They need to be facing down when you mount the lenticular filter. Here's a cross section. You see the cardboard, and in the middle is a propylene surface that is there for drainage to make sure that the wine flows nicely to the collector at the center of the housing. Here's how you assemble them. You stack them on top of stainless steel discs that basically protect the model from the pressure of the wine. Coming too fast, it could break or damage the model. So you have this protection here, the shields. And then you mount maximum 4 models on top of each other, and then they're all sealing in between. Composition is the same, exactly the same. He said is the same cardboard they come from. So cellulose, perlite, DE, synthetic resins, and then there is that drainage propylene that we saw in the middle, and the reinforced central stud for when you mount them in the housing. It's an interesting little scheme on how the wine goes in, fills up the housing, and then it goes into the disc and comes out clean. When you assemble the model filter, we've already seen, make sure you check each individual model for the direction. Those little triangles have to face down. Check the seals like we saw for the sheets. They can create problems if they're not there. Inside the models on the central stud, check the alignments. Always remember those stainless steel plates that protect the models. And then close the housing, and the pressure that they withstand is about 2 tons. So they won't move from there once that pressure is in. Around water for about 5 minutes. Got to be cold water. Empty the system, and then you can start sterilizing with hot water. We normally want to sterilize with hot water at 85 Celsius for at least 40 minutes, or you can do steam for 20 minutes at 1 atmosphere, and then you can empty the system again. To preserve the models, once you're done, you have to put a little bit of pressure, maybe 1.5 pressure with nitrogen to block the yeast. This way you can store the models overnight. If you have to store them for longer, probably you want to use some potassium metabite with citric acid, but they won't keep for too long. When you use these filters, you don't want to exceed the pressure of 1.5 bars. Like we said for the sheets, avoid pressure bumps and never do backflow. For the regeneration, you can do that. They will increase the life of the filter, so you will have better delta pressure. In this way, you solubilize all the deposits that gather in the discs. So when you wash, make sure you wash each housing individually. Otherwise, you're going to carry over those deposits from one housing to the other. Always do in current, so no backflow. Use plenty of water, plenty of hot water at about 50 Celsius, about 10 minutes. You're going to get a good sterilization if you go at, we said, 85, 40 minutes. But always respect the flow. Here we see again those temperature, respect the flow. If you do that, you're going to inhibit the microorganism, eliminate the microorganism. Avoid at the end a quick cooling to avoid thermal shock. There's a little scheme that shows you what it means regeneration, what it means sterilization. So in terms of temperature and in terms of time. When you store the models, like I already mentioned, you can do it for a short period, pretty easy with a simple regeneration. More than 24 hours, you will want to sterilize those. And then when you do a sterilization, you want to do it thermal, not much of a chemical. The chemical is more to store them on potassium metabolite, like we said, and a little bit of pressure. And when you put them away, you got to have a suitable room. It got to be free of odors. Those sponges will absorb the odors if you have odors around. No humidity, so avoid any situation that could give you mold. So have a ventilated area and put them back in the original package. So I hope you enjoyed the presentation. I hope you come out with a little bit of learning. And next time, I hope I'll see you in person. Have a good day.